Hello, good day, class. This is my second video on Laplace transform and also my second video on this channel. Now, for this video, I'll be giving more examples on how to find the Laplace transform of a function of t. And don't forget, when you are finding the Laplace transform of a function of t, we tend to get what? A function of s. What do I mean by that? Now, it means if you are looking for the Laplace transform, let's say Laplace transform. Now, in our previous video, I said when we are looking for the Laplace transform of a function of t, Laplace transform of a function of t, we tend to get what? A function of what? A function of s, which I explained that when you are looking for the Laplace transform of 1, the result is given to be what? 1 over s. Now, for this video, we are going to what? Solve more questions on Laplace transform. Now, the very first question I'll be solving is, how do you find Laplace transform of t? Laplace transform of t. Don't forget, the definition of Laplace transform is given to be what? The definition of Laplace transform of a function of t is given to be what? We have integral from 0 to infinity, exponential minus st, then multiplied by what? A function of t dt. Now, by making comparison here, our function of t is what? T. So what does that mean? How do we find the Laplace transform of this function? So it means we are going to have integral from 0 to infinity. Then we have exponential minus st. Then we have what? T. Is that okay? Then the t. Now, how do you solve this question? Now, recall from integration by part. So we have to make one of the function, we make it one to be u, and the other one to be what? To be v. Now, which one do we make u? We make t to be u. Let u to be equals to what? T. And let our dv equals to what? Exponential raised by what? Minus st. Now, given our u to be t, what does that mean? It means our du will be given to be what? 1. Also, from your dv to be equals to exponential raised by minus t, it means our v will be equals to what? Minus 1 over s exponential minus st. So how do we integrate by parts? So recall from the formula of integration, which means what? uv minus integral of what? V du. So what does that mean? It means we are going to have what? Our u is what? T. And our v is what? Minus 1 over s exponential minus st. What does that mean? It means I'm going to have limit as t tends to infinity of what? What's our u? Our u is what? T. And what's our v? Our v is what? Minus 1 over s exponential raised by minus st. That's minus 1 over s exponential what? Minus st. So what does that mean? Our t is tending to infinity. It means we are finding limit from 0 to what? To t, where our t is tending to infinity, minus integral of what? Of 0 to what? To infinity. Yes, we have v du. V du. Our v is what? 1 minus 1 over s. So the minus will make this one to be what? Positive. That will give us what? Plus 1 over s. Then we have what? V du. Our du is 1. So we have exponential minus st dt. And what does that mean? It means we are asked to find what? I'm going to have what? 1 over s. And if you look at this very well, from our first example, this is more like finding what? The Laplace transform of 1. The Laplace transform of 1. What does that mean? It means 1 over s multiplied by what? The Laplace transform of 1. And don't forget, the Laplace transform of 1 is what? 1 over s. So it means I'm going to have what? 1 over s multiplied by what? The Laplace transform of 1, which is what? 1 over s. So it means when you are finding the Laplace transform of t, I tend to get what? 1 over Laplace transform of t. It tends to what? Get what? 1 over x squared. And mind you, provided that what? S is greater than 0. So it means if you are asked to find the Laplace transform of t, your result is what? 1 over x squared. So by doing so, now when you try Laplace transform of t raised power 2, t raised power 3, t raised power 4, then we tend to get a what? A general form of of t raised power n. What am I trying to say here? What am I trying to say here? Laplace transform. What am I trying to say? Now it means if you are finding Laplace transform of what? Of c raised power n, it tends to get what? N factorial over x raised power what? N plus 1. And don't forget our n belongs to a what? A set of natural number. So from this general formula, so if you are asked to find Laplace transform of, let's say our n, let's start from 0 first. Now, if our n is equal to 0, it means I'm finding Laplace transform of t raised power 0. And t raised power 0 is what? Is 1. So looking for Laplace transform of 1, we get what? 1 over s. So since we said n belongs to natural number, so let's start from 1. So it means the Laplace transform of 1 will give us what? Of 1 will give us what? Where our n is, where n is equals to 1. So it means I'm going to have what? 1 factorial over x raised power 1 plus 1, which will give us what? 1 over x squared. Also, Laplace when n equals to 2, when n equals to 2, Laplace transform of t raised power 2 will give us what? 2 factorial over x raised power what? 2 plus 1. That gives us what? 2 over x raised power 3. Also, the Laplace transform of t raised power 3 will give us what? From this general formula, we have what? 3 factorial over x raised power 3 plus 1. That gives us what? 6 over what? Over x raised power what? 4. So it means until we get what? Laplace transform of t raised power n, which will give us what? N factorial over x raised power n plus 1. So this is the general formula of t raised power n. Now also, the next example we are going to talk about is how do you find the Laplace transform of trigonometric function? How do you find the Laplace transform of trigonometric function? So I'm going to give you two examples on that. The first one will be on cos, and the second will be on what? On sine. So how do you do that? Laplace transform. Laplace transform. And before we continue, I would like us to recall some identity function, which the movies talk about. Now, what did he say? He said cos theta is equals to what? Exponential I theta plus E minus I theta over 2. Is that true? Yes. Also, you also make mention of what? Of sine theta is equivalent to what? Exponential raised by what? I theta minus exponential minus I theta over 2i. So we are going to make use of this identity. Now, the first question we are going to be solving is what? How do you find the Laplace transform of cos theta? Laplace transform of cos theta. How do you find the Laplace transform of cos theta t? Let me make it t. Let me make it t. Or better still, instead of us using theta, let's use another letter which we generalize the theta to be of any form. So I'll prefer to use letter A. I'll prefer to use letter A. I'll prefer to use letter A. Let's say AT. So what does that mean? It means by definition of Laplace transform, we have integral from 0 to infinity, then exponential minus st multiplied by what? A function of t. And what is the function of t? We have what? Cos what? At dt. Now recall from the movies that cos theta is equal to this. What does that mean? It means I'm going to have what? Integral from 0 to infinity, exponential minus st. Now, where we are having this cos theta, we replace it with what? With this. Is that okay? So, which means I'm going to have open bracket exponential I at, yes, plus exponential minus I at, close bracket, dt. And don't forget, we have 2 at the bottom. So having 2 at the bottom, it means we can easily have our 2 here, which is 1/2, not 2, 1/2, which can be easily replaced at the back of the integral, which we have 1/2. So what does that mean? It means I'm going to have what? 1/2 limit as what? As t tends to infinity, integral from 0 to t. This t is tending to what? To infinity. Exponential what? Now, using this exponential raised by minus st, using it to open the bracket, it will multiply this, and it will also multiply this. So it means I'm going to have what? We have minus open bracket what? Yes, t is common for the first and the second one. Also, we have, are we there? T is common for the both. We have, okay, instead of that, let's say, so what does that mean? Now, so it means t is common for the both. So I'm going to have s plus what? IA, close bracket t. Is that okay? Dt plus this second value of the integral plus what? 1/2 limit as what? T tends to infinity, integral from 0 to what? To t, exponential what? I'm going to have what? Minus s minus ia, close bracket what? T dt. So what does that mean? It means now, since 1/2 is common for the both, can we bring it out to be what? 1/2. Now, when you integrate exponential raised by what? Minus s plus ia, we are going to have what? Minus, that'll give us what? Limit as t tends to infinity, we are going to have what? Minus 1/s what? S plus ia exponential minus s. Can we use the top? Let's move to the top. For a better view. Let's move to the top. Let's use the top. Let's use the top. So what does that mean? Don't forget, we have 1/2 here. So when you integrate this, I'm going to have what? 1/2 limit as what? T tends to infinity, yes. We have what? Minus 1/2 s plus ia exponential what? Minus s plus ia. Then t, where our value of integral runs from 0 to what? To t. Don't forget t tends to what? To infinity. Also plus this. So it means I'm going to have what? Plus 1 over 2. Yes. Limit as what? T tends to infinity. So when you integrate this, I'm going to have what? Minus 1 over s minus ia. Yes. Exponential what? Minus s s minus ia t. This one from what? From 0 to what? To t. Now, when you test this one, if you subtract the upper minus the lower, so if you are substituting infinity here, for the upper limit, this will tend to 0. And minus the lower will give us what? 0. Is that okay? And the minus at the back of this will make this one to be what? Positive. So it means I'm going to have what? 1 over 2. 1 over 2 is here, and 1 over 2 is here. So that is common. So we factor it out. So I'm going to have what? 1 over s plus ia. Also, the upper limit minus the lower limit. For the upper limit, this will tend to 0. And for the lower limit, this becomes 1. And the minus at the back will make this one to be what? Positive. That will give us what? Plus 1 over s x minus ia. That will give us what? 1 over 2. Yes. The SM of s plus I and s minus I is this. So it means the LCM is what? S plus IA and s minus IA. So what does that mean? This divided by this, I'm going to have s minus ia. That is s minus ia plus this divided by this, I'm going to have what? S plus ia. This we cancel this. I'll be left with what? 2s. Don't forget we have 1 over 2 outside, 1 over 2 outside, 2s over what? When you expand this bracket, I'm going to have what? S x squared plus what? Plus a squared. So these two will cancel these two. So it means I'm going to be left with what? S over what? X squared plus what? A squared. Provided that is what? X is greater than A. So what does that mean? It means if you are asked to find the Laplace transform of cos 80, the answer is this. Is that okay? This is the answer. So also, the next question I'm going to do is, how do you find Laplace transform? Example. Let's say our function of t is equal to what? Sine 80. So how do you find the Laplace transform of this, of sine 80? How do you find that? Don't forget, from definition of Laplace transform. So it means if you are finding the Laplace transform of what? Of sine 80, I'm going to have what? Integral from 0 to infinity, exponential raised by what? Minus st, then multiply by the function of t. And what is the function of t? Is what? Sine 80. Sine 80 dt. And don't forget, recall that sine 80, sine 80 is equivalent to what? Is equivalent to exponential I 80 minus exponential minus I 80 over 2i. So since we know that sine is equal to this, so can we substitute? So it means I'm going to have what? Integral from 0 to infinity, exponential minus st, open bracket, what? Exponential I 80 minus exponential what? Minus I 80 dt. And don't forget, we have 1 over 2i here, so which can be put outside the integral. at the back of the integral. Now, opening the bracket, I'm going to have what? 1 over 2I limit as t tends to infinity, integral from what? From 0 to t. Don't forget t is tending to infinity. Exponential what? Minus s s minus ia, close bracket t. Also, that is the t. Plus, minus, we have minus here, minus 1 over 2I limit as t tends to infinity, integral from 0 to what? To t. Yes, this is multiplying this, don't forget. So I'm going to have what? Exponential minus s plus what? Plus ai, then close bracket t dt. So what does that mean? It means I'm going to have what? 1 over 2I. Now, when you integrate this and you subtract the upper limit from the lower limit, I'm going to have what? I'm going to have what? 1 over s minus ia. Also, if you do the same thing here, when you integrate and you subtract the upper from the lower, I'm going to have what? I'm going to have minus 1 over what? S plus ai. Now, finding the LCM of this, I'm going to have what? 1 over 2I close bracket. Now, the LCM is what? We have the LCM to do s minus ai and s plus ai, which will give us what? S plus ai minus s plus what? ai. This will cancel this, and which I'm going to be left with what? 1 over 2I, open bracket what? 2ai over x squared plus a squared. So we cancel 2, I will cancel I. So it means I'm going to have what? A over x squared plus what? Plus a squared. Now in this class, we are able to derive the Laplace transform of some function, which I'm going to recall again. Now, what are those functions that we look for? We're able to find the Laplace transform of a function of t raised to power natural number, which we said the general solution is given to be what? N factorial over x raised to power n plus 1. Also, we'll be able to find the Laplace transform of cos at, which we said the answer is what? S over what? X squared plus what? A squared. Also, we'll be able to find the Laplace transform of what? Of sine at, which is said the answer is what? A over what? X squared plus what? A squared. Now, in our next class, we'll be talking about how to find the inverse Laplace transform. How to find the inverse of Laplace transform. So I believe you enjoyed this video. Don't forget to like and subscribe to get more videos on this channel. Thank you.